for this particular problem, we're going to choose two ways to solve this system of equations. All right? I'm going to show you three, but you get to choose two of the three. It's your choice. But here's the first one. We're going to do it by graphing. See how I graph right here? I'm going to graph both these and find the point where they cross. That is one way to solve it. All right? It's not always that accurate, but it's one way to solve it, and you might like that method, and you can do it. So what I did for this equation, this first one, is I added the 2 over, canceled, and I got it in slope-intercept form. And you can see here in the orange, I start at 2, which is that number, and my slope is 1. So go up 1 over 2, up 1 over 1, up 1 over 1, up 1 over 1. So start at 2, and I go up 1 over 1. There's my point. You want to put a lot of dots so you get an accurate point where they cross. That's the problem with this. It's not always accurate. This one I rewrote, so I minus the 4x over. This canceled, so negative 4x and 6 don't combine, so I wrote it like this, the brown. Negative 2y stayed over here. Divide both sides by negative 2. That cancels. Negative 4 over negative 2 is positive 2. 6 divided by negative 2 is negative 3. So here in the green, you can see I start at negative 3. My slope is 2, so I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And as I keep my graphs nice and accurate, you will notice I hit right there at 5, 7. Again, you have to be very accurate graphing these two to find the point where they cross. Be very patient and accurate. Now we verify it. Here's how you verify it. You take the 5, 7, and I plug those values into both equations. So I take this one right here, and I put 7 for the y. There it is. I put 5 for the x. You can see right there in red. And I simplify the left. 5 and 5 is 5 equals, they're equal, so that's true. Same thing here. I take the 5, plug it in for the x. Take the 7, plug it in for the y. There in purple. 4 times 5 is 20. Negative 2 times 7 is negative 14. And then 20 minus 14, 6. 6 equals 6. True. So we just verified that that point is actually the point where we cross. That is one way of solving this systems. Now there's other ways, and we're going to show the other two next. Graphing is just one way, and it's actually the most inaccurate way, but it is a way to do it, and you may do it that way. So we're going to do substitution next. So I have the same two equations right here in black, and what I'm going to do is I look at one of them, I look at one of these and say, hey, oh, that equals a letter. So I'm going to take the piece that equals a letter and stick it into the other one. Now, it's not always going to be equal to a letter, so you might have to change it around. So you could plug it in, but a lot of times it will be set up so you can just simply plug it into the other one. So since this is the same as x, I can replace x in the other equation with y minus 2. So if you look here in brown, I have this equation right here, but where there was an x, here in pink, I replaced the x with the 7 minus 2 because these two are equivalent. And then I'm going to solve this. So I distribute the 4. 4 times y is 4y. 4 times negative 2 is negative 8. Then I simplify the left side, so 4y minus 2y is 2y. Leave everything on this side. Then I'm going to add the 8 over. That cancels. It's 14. And I divide both sides by 2. So I get y is 7. Alright. And then I take that 7, I go plug it into either of these originals. Well, I notice the top is easier. So I'm going to take that 7 and just stick it right there for the top equation. It doesn't matter. You could choose this equation. I just think it's a lot harder. So choose the easier one. When I put 7 minus 2, I get 5. See right here, I checked it. When I put that right there, I wrote it over here. So 7 minus 2 is 5, so x is 5. And that coordinate is the same, 5, 7. We checked it earlier on the other problem, so this is the same answer. So that's another way of solving. Now the third way of doing it is elimination, which is also very useful. Elimination is also called linear combination by some people. Anyway, there's the same two equations. What I'm going to do here is I have to rewrite them. See right here? I have to rewrite this first one so it kind of matches the other one. See how they kind of stacked, the x is stacked, the y is stacked, the number is stacked. So I've got to rewrite this one so it matches the way this one looks. So I'm going to minus the y over. Those can't combine, so I just have x minus y. Negative 2 over here still. Then what I do is, okay, I see this, and I go, okay, I'm going to rewrite this here in blue. Because I want it to be, so this is x, y, and then a 6. So I want to make it look like this one. But when I look at this, it doesn't match this. I need to have one of the letters drop out. So in order to, I looked at 4 and 2, which one's smaller? Well, I think 2 is smaller, so since that's a negative 2, I need to change this y right here to be a positive 2. Again, I want to be able to cancel this out. So I need, in order to cancel, I need to create this y into a positive 2. So I think, and I go, oh, that means I must multiply this by negative 2 to make it a positive 2. So if I multiply negative 2 to all three, because you can multiply negative 2 by both sides. When I multiply everything by it, that's basically multiplying both sides by negative 2. Anyway, I multiply it by negative 2, multiply by negative 2, and multiply by negative 2. There I get that. Move it up here. These now cancel. So again, my whole goal of rewriting this and then multiplying by something so something will cancel. And I choose the easier one to cancel out as possible. So, all point of canceling, when I add down, it cancels. When I add down, I get 2x. When I add down, I get 10. When I divide both sides by 2, I get 5. That should look familiar. X is 5. And then I take this answer and plug it into either of the originals. I chose this one. So see, I rewrote it right here. Stick the 5 in for x, because x is 5. So I took a 5 right there. Add the 2 over, y is 7. See how these answers agree? They should. Now this, in this situation, is a little bit longer for this particular problem. A lot of times you get problems and the x's and y's are lined up, and this is a really easy. In the end, this one was difficult. This one ended up being a little bit easier. Sometimes it depends on how it's set up, which one's better to be used. And so you can solve by elimination right here, substitution, or like you could see above, you can also solve by graphing. It's your choice. You have to do it 2 ways. It's your choice on which way you want to do it.